So this problem is a speed trap problem, and the problem basically asks us to express f as a function of x over the intervals 0 to 75. So the first thing I want to focus with is the 0 for the intervals. So with this, between the intervals 0 and 55, because that is the posted speed limit. So f in this case would equal 0 because you are not going over the speed limit, so there's no fine, which f equals the fine amount. So that's the first one for this problem. So the second function for this problem would be taking the intervals 55 and adding the first over 10 miles per hour, which would make it 65. And then to find f, we set f equal to x, which is the driver's speed, subtracting it from 55, which is the posted speed limit, and timesing all that by 5, which is the 10 miles per hour additional charge, and adding that to 70, because that is the fine amount when you go over the speed limit. So this becomes our next function between the intervals 55 and 65. So to find the final and third function between the intervals 65 and 75, because you're adding another 10 miles per hour to 65, you want to first put 65 into this equation so that you can get what the fine amount is when you go over the first time. So you do that by plugging 65 into this equation, saying it equal to x 65 minus 55, adding 70, so we get f equals 120. So this is the fine amount for the first time you go over 10 miles per hour, which we will use to get the final function for the interval 65 to 75, and that would be setting f equal to x, subtracting it from 65, because that is the interval 65, timesing it by 10, as that is the next 10 miles per hour charge, and adding that to your fine charge of 120, which would make the function then equal to taking the first fine amount between the intervals 0 and 55, then writing the equation again for the second one that you found, which would be 5x minus 55 plus 70 over the intervals 55 and 65, and then taking the third equation here and putting it in, so that x minus 65 times 10 plus 120 over the intervals 65 and 75, which is the function.